Good morning, good afternoon, everyone. Thank you for joining us today. Today we'll cover a great deal of topics, so we'll move through rather quickly. The topics today are to retrofit or to replace, and some guiding rules for you out there, and some reasons why. We're also going to cover some products that can be used for retrofitting and other products that are new fixtures that are generally new to the industry. And we're also going to debut to you today university.maxlite.com through some screenshots, and we'll invite you to use the website for new employees, for customers who might need briefing on product or maybe just an introduction to lighting. We've had reps who are already using this for distributors. We've had distributors who are using it for customers, and we are now out of beta and the site is live. You can find a link from maxlite.com or by going directly to university.maxlite.com. First, real quick, we'll get it out of the way. Why should we be replacing these HID lamps? And well, we all know that they're power hungry. A lot of people don't know that there is a large amount of mercury inside of these lamps, is another good reason. The long restrike period, which more and more is becoming a motivation to switch over to fluorescent in gymnasiums, multi-purpose rooms, in schools. The poor CRI, which is just speaks for itself. I think we are, as educated consumers today, we know that the higher CRI leads to better visual experience and just certainly highlights whatever it is in our view in a much more accurate way. And then the steep lumen depreciation, which this graph depicts. Notice the metal halide, which depreciates very quickly. It's depreciated by about 30% at the 5,000 hour mark. I want to remind everyone that if these products, HID, fluorescent, other light sources, were held to the same standard as LED, metal halide would be rated as a 5,000 hour lamp. L70, typically around 50,000 hours, is associated with LED. 30% depreciation is the point in which to make the decision on replacing those fixtures or not. With other light sources, we just wait for the light source to actually die out. So apples to apples, these products have to go for a myriad of reasons. A lot of people are calling this technical department often asking about retrofits for LED products. I will share with you that there might be some exceptions on where an LED retrofit might work. An example could be a acorn type fixture or a big large globe or acorn post top type fixture. The reason that I say that they'll probably be okay there is generally there's a lot of open air. Generally they're only on in the evenings, and I think the thermals there are less of a concern than in other fixtures such as wall packs and cobra heads, area lights, shoe boxes, and so on. LEDs in those fixtures, I think, are a great unknown in that you really don't know how long the product's going to last. You don't know what the lumen depreciation is going to be. The product, unless it was LM79 tested in a specific fixture, a fixture-specific retrofit is an exception to what I'm trying to say, but a general retrofit type screw-in or hardwire LED bulb that you could just put in this fixture or that fixture without concern for thermals and the like, well, it's dangerous. Our advice has been and continues to be that without a rebate, consider retrofit for the fastest ROI, and with a rebate, consider new fixtures, again, because with the rebate dollars, you can achieve a very quick return on investment. Now, as a platform to begin, one must and should understand scotopic lumens, also known as pupil lumens. We're not going to get into that too much today, but I will say that it's no coincidence that these outdoor products are selling 50 to 1 or higher, 5,000 Kelvin versus other warmer Kelvin temperatures. Kelvin temperature as well as CRI contribute to scotopic, or known as pupil lumens. SP ratio is something that is absolutely a contributor towards energy efficiency, and if you're in the energy efficient lighting business, a full understanding of scotopic lumens is important for you and your customer. We will send you links to this information that we're providing here so that you can review it on your own time, and we emphasize a scotopic lumen webinar. It's about 20 minutes. We'll send you a link for that as well, where really it gets in depth on scotopic lumens, how to understand it, why it's so hard to explain, and how it's somewhat subjective. So for more information on that, please do take some time to visit the scotopic lumens webinar, and you will see how it contributes towards energy efficient lighting recommendations and why the best-selling outdoor products right now are in 5,000 Kelvin. Some of the options we have on some of these typical retrofit opportunities. Let's take a look at recessed cans. For recessed cans, we have an option of putting in a brand new LED fixture, which is a good viable option. We have screw-in LED products, which we'll talk a little bit about in more detail later. And we have high-power CFLs. Now, CFLs are generally associated with table lamp type applications, hotels, residences, and the like. But there are high power CFLs that are designed for commercial, industrial applications where high temperature is associated. We recommend only high power CFLs that have the proper thermal combating technologies integral to the product. Wall packs. Basically, wall packs have been passed by for retrofits for the longest time, generally high pressure sodium and metal halide. The last year or two, mainly due to utility rebates, there's been a big push for new LED fixtures, and MaxLite has a full line of LED wall packs, including the traditional look that you see here, as well as the full cutoff type wall packs. But another option for that existing wall pack is a high power CFL retrofit. For these types of high power CFL retrofit, one must bypass the ballast by bringing the power directly to the socket, Mogul or Edison based socket, and then screw in the appropriate CFL. I would say a screw-in LED bulb in this application could be risky. They are airtight fixtures. They are generally only on in the evenings, which helps, but no thermal testing could lead to a short life. And remember, a short life with LED could be 2 years, so well after the purchase is made, but at the time promises of 5, 7, 11, 13 years of maintenance-free labor, which is associated with LED, you have to be sure that you're going to get that type of life out of it, and with a retrofit, without additional testing, one just doesn't know. Low bay, high bay applications. This is probably the most popular application for high power CFLs. The typical retrofit there is linear fluorescent. By moving from the HID to some type of fluorescent technology, we're increasing the efficacy. We're allowing instant-on technology. In some cases, we can use sensors such as motion sensors for additional savings. So linear fluorescent, T8, T5, high power CFL, all good options. If you want to maintain the look of the facility, for instance, often in retail where they're using these types of high bay fixtures, they want a lot of uplight as well as downlight. Often linear fluorescent fixtures do not provide the quantity of uplight that they're looking for, so a high power CFL is the best option in those applications. Applications such as warehouses or maybe manufacturing facilities where the look of the ceiling and the look of the facility is not as important as the foot candles on the floor, on the work surface, on the pallets. In those cases, linear fluorescent is a great option. And for surface mount being canopy, garage lights, parking facilities, fuel stations, and the like, new LED fixtures is the overwhelming choice today due to utility rebates, but high power CFLs are working in, I would say, up to about 15-inch round or 12 by 12 type square fixtures, where again you bypass the ballast and just screw in an integral high power CFL. Oftentimes these fixtures have mogul sockets. You want to make sure that you have in your arsenal, when you consider high power CFLs, the mogul to Edison converter, because often you want to put in, say, an 80-watt high power CFL where there was a 250, say, high pressure sodium with a mogul socket. It's a good replacement as far as perceived appearance. It looks great, looks even brighter, so mogul sockets are important as well. Now, to view some of the products that we've just talked about, we will use some slides, some snapshots of MaxLite University. Before we go ahead and do that, I just wanted to spend a moment with you to tell you a little bit about the university. It's basically been put up for our customers, our representatives, and most importantly for our employees. We feel that having employees who have a complete and full understanding of the products, the services that we provide, the marketplace, the general business environment is good for you and your customers as well. We do this by bringing to you the latest information on why lighting is what it is, repair, replacement, retrofit options, as well as to compare competition with each other, listing criteria like UL, Energy Star, Design Lights Consortium, and the like. We do this through three basic modules. One is the product training modules, which are very MaxLite specific. The other is more or less a lighting 101. That is not yet public. We're still working on that. Look for that in about a month to go public. Last and certainly not least is basically other resources that are available to you concerning the marketplace, the lighting environment, new technologies, and the like. You'll find resources in there, links to the Lighting Research Center at Polytech Rensselaer Institute in New York, Osram, Sylvania, which has some great modules put together on LED technology and general lighting technology. The ALA, the American Lighting Association, links to some of the webinars that they make available to their members, and much, much more. So keep checking back there. You'll see that section change often. The product training modules will be updated as often as the product lines are updated. And the Earn Your Lighting Degree portion, that will be pretty static. That is the place where you would want to send your new employees or to those who might want an introduction to lighting and so on. And there's lots of other good stuff. So on your own, please do visit university.maxlite.com. Click around. I think you will find a wealth of information. And please do send us any feedback you might have. So let's get into the products. We talked initially about recessed cans and using screw-in products as an option. I wanted to use that as a bit of a segue to talk a little bit about Energy Star when it's concerning LED PARs, R lamps, and MR lamps. Now, in the past, with, say, CFLs, the Energy Star labeled, and I see that there's at least one or two Energy Star folks who have joined us today, and I apologize to them in advance, but I always have to speak my mind. So in the past, Energy Star has represented the latest, most cutting-edge technology. In the case of CFLs, those with the Energy Star label were most likely better performers than those without, and you can count on it really without even looking at the specs, just by seeing that Energy Star logo. But I assure you that is not the case with LEDs today. Let me give an example. Pick your favorite LED manufacturer. There are many: Cree, Osram, Philips, Seoul Semiconductor, Nichia. I hate to leave anybody out. There's just so many. And by the way, MaxLite uses different LED manufacturers for different products depending on the application. But not to get off track, that your favorite chip manufacturer, LED manufacturer, is coming out with a new generation of a existing LED family or a whole new family of LEDs every 4 to 6 months. The Energy Star testing to get an LED product through the requirements is at least 6 months' time. So when I want to use the latest chips with the highest efficacy, of course we would only consider LEDs that have LM80 data. The Energy Star labeled products are not necessarily the latest, and the examples are here. Look at my performance rated LED products: 6 versus 7 watts for a par 20, 12 versus 11 watts for a par 30, 13 versus 17 watts for a par 38. You can see right out of the gate that the power consumption is lower for the performance grade, higher on the Energy Star grade. Let's jump into the next screen. Interrupt myself here to talk about, you'll notice as you go through university.maxlite.com, you'll notice often blue underlined links. These are exactly what you think they are. They are links to a definition of that term. In this case, Blake has illustrated for you the LM79 definition. But all throughout university.maxlite.com you will find these, and it will open up a separate tab and bring you right to the definition. Often there are graphical images to support the definition as well, and that all links to lighting terms and definitions, which you can view directly from university.maxlite.com.